Galileo in modern times, basically. Now, over the, if you're wondering why we are building a stage show, then you must all realize at some point of time that astronomy is exciting. It is, but it often feels distant, abstract, too technical sometimes. And you can see from the word cloud that it can be intimidating. So our team thought of making a show where we would basically engage audiences, we would entertain them, we could also teach some concepts of physics, astronomy there, and it could be useful to educators, and maybe also connect the simple experiments to very modern telescopes. We at our center at Ayuka have a huge lot of low-cost experiments collected together over many years, adapted to local material, and then properly documented. You can have a look at this website that I've mentioned on the slide. And you could also probably look up the originator of this idea, Mr. Arvind Gupta. He has a TED talk, so you could look him up. So having this collection that you can see, and two of the pictures here show some low-cost activities being done. We thought that why not, better this, advance this optics stage show into something which has a more effect. And so we brought in a surprise visit from Galileo. You can see that the story premise basically begins with two of our modern presenters, who we just call Telescope Boy, Optics Girl, and they begin a normal demo show with nice highlights, etc. And then they are suddenly interrupted, okay, by the presence, the appearance of Galileo Galilei himself on stage, where he comes, and we have to always find a bearded guy for that. But that we happen to find. In fact, one of them is me here in the picture. So that basically adds some dramatic tension, and the audience is suddenly drawn to the effect that it has. And they also find a connection with Galileo, who is not the presenter. He's just a stranger as them in the stage. But he's also learning that what is this magic going on here? Because, most of the things happening on stage seem magical to him. But he slowly realizes that most of these ideas have come from the discoveries and the facts that he has given in the past. So in particular, we see the Galilean telescope. And here I show a telescope which is made of low-cost material, except we don't use low-cost optics. We use very high-quality optics in it, so that that's the basic, holy grail of astronomy. We call it Galileo scope plus because it's an improvement on the Galileo telescope. And just looking up on the internet, I actually saw that the museum in Florence has actually come up with a modern replica of Galileo scope, which you can see here in the middle, and it looks very similar to our telescope. So they start taking some credit for that. So this Galileo scope telescope and many others, more than 300 of them are made in DIY telescope workshops in India by our team. It's also a part of a lovely project where we are, with the help of IAU's OAO funding, we are helping developed countries get optics material and then make low-cost telescopes with local materials. So training and all is given by us. So all this has been happening here. And so we thought, let's introduce that to people as well through this talk. Now, the appearance of Galileo, it's dramatic. It works because it introduces humor. I have to develop a Italian accent sometimes to make it funny. Adds narrative continuity. It adds, emotional connect with the audience, and it also brings the human element. So we talk about Galileo and his struggles as well, compared to the presenters who have it very easy. So, of course, let me show you some pictures of the show. You can see that we have a really good and effective stage show there. People get to see ray diagrams with actual light, not with just figures on a board. Galileo also gets to see the working of a Galilean telescope by himself. He also gets to use a laser. In fact, I particularly feel the dress we got designed looks more like a Jedi than Galileo himself. But laser really fascinates him. That's what we realized, as well as the audience. And he also gets to know about the future of astronomy and what happened after him, how the Newtonian telescope came, and how many other different types of telescopes have come and evolved to the mega projects of the world, like the 30-meter telescope. The TMT, of course, also happens to be one of the projects we were supporting outreach for through this drama. So we thought of this script when we were doing a big outreach project, All India National Outreach Project for TMT, and we then sat together and designed this. So we identified the 3 axis points, the 3 major tips of this triangle, which are science, theater, and engagement. All should be properly balanced. And we laid emphasis on the storytelling aspect. We had to think about timing, visual impact as well, and audience interactions were a necessary thing. In the process, we of course first identified the concepts, which we have a huge collection of, but arranging them into a proper arc of narrative was very important. We had to add in the humor, the conflict. For example, Galileo is not very welcome at the beginning because the presenters want to go on with their show, but then they welcome him because they know it's a very historic occasion for him to be there. Yeah, and then the demonstrations are integrated into it. What did we show? So we the identified concepts are listed here. I'm not going to go through all of them, but you can see that we identified them. These are very basic. Many of them are part of syllabi of school children in India. And then we made exciting demonstrations possible on stage, which were very effective in conveying things like ray diagrams, image formation, aberrations, etc. In this, of course, we have to end with the interaction with Galileo himself. He cannot be a stage person, so he comes and poses with audiences, gives away goodies, gifts, etc., to make it more memorable. So the demonstrations, when we chose them, we realized that we had to bring in the cost factor, which hampers many communicators. It cannot be just us who's got some funding and we are going and showing some high fancy show. So it had to be very low cost and high impact activities. We also realized that the activities we were showing in classrooms may not be effective when the audience is sitting 20 meters away from you and you're showing a very small thing. So the nuances may be lost. You might remember some of the props were very big as the presenters themselves. So they had to be redesigned for scale and visibility. Of course, so small experiments were made bigger. We used lasers, projected visuals. We also did not compromise on scientific accuracy. However, we had to bring in the entertainment factor. And so there are, depending on the audiences, we have layered explanations. The timing also was to be adjusted. So we had to bring in comic elements where the next demo was being set up, right? So there had to be script redesign, iterations, improves sometimes happen because something is failing and Galileo just has to go into a monologue or something because he's not part of the demos in a way. Audience diversity is considered because if there are mixed ages, we have to have different levels of humor and interaction. And so all these factors were considered, and if there was a problem, it was solved. Till now, we've had 8 performances of this show to about 2,500 audience. We have had presentation in a science communication, astronomy communication conference, very similar to CAP, but in India itself. And we see a rise in the queries, emails, internship requests which come to us where we have people asking for DIY telescope making. They're also showing more interest in the 30-meter telescope and what's happening with it. And it has also been used by some other teachers. So we've got reports of that, and since the script has been given to them, which is part of our outcomes, they've been themselves able to use parts of this in their own classrooms. So this is what we have, and hope that we could probably take this to a national level with a set of shows. And final slide, I'll share the key lessons for us from this project towards an effective outreach show. The major things that we considered was strong storytelling, visual clarity, emotional engagement, scientific authenticity, iterative testing, and also finally, of course, for all of us, cost feasibility. So if you bring science as a story, it becomes more memorable. So with that, I'll come to my contact slides. If there are any questions, I'm happy to take them now or as the chair wishes. These are our contact details. You can scan the QR code for all our link tree, which gives you all our contact details, social media, etc.
Thank you, Samir. Okay. I don't see any questions in the chat from our online chair. Do we have any quick questions? All right. We've got time. Go ahead for one quick question. Thank you.
Hi, Samir. I wanted to ask you if you have a web page, or if the not only the results but also all the things that you did for this project are available also for others, maybe to your use. And also, I wanted to know how much time did you get from the idea from the concept to realizing it, and how many people were involved in the project.
Right. So, to answer your question, right now we don't have a website, so we are concentrating more on the shows and many other activities that we do here. But I will be able to help you through email if you just email me, and I can also share the script, etc., with you directly that way. The people involved in our team are about 4 to 6 people, and as you could see that we have, the people who do the shows have been different. I think the original team which came up with the script was 2-3 people, and it took about 1 or 2 weeks to figure out and do all the iterations on stage, trials, etc. But I think we were very well ready, except for the costume for our first show that we did 3-4 years back.
All right. Thank you so much, Samir. We have to wrap up and move on to our next speaker since we have 6 more in this session.
Thank you so much.
Let's give... next, we have Livia Giacomini from Italy. Spacewalk, walking the solar system in your city. Please do your best to keep to 10 minutes. It might be hard to hear when I give you time.
I will try to do that. Okay, I can see my slides. Can I navigate them? Yes. Hello, I'm Livia Giacomini from Italy, and I will be talking about Spacewalk, which is a project to use augmented reality to walk in your city, exploring the solar system. So let's start from the beginning. The problem we wanted to address, and the problem is very simple, and all astronomers have the chance to meet it one time or the other. Astronomical distances are very hard to figure out, to understand, and to feel for human beings, and images that represent the solar system do not help us at all to understand how big these distances are in reality. So we usually see images like the one I'm showing, with all the planets aligned and very near to the sun and near one to the other. Textbooks, at least in Italy, do not help either. Images in textbooks also show the planets that are very near one to the other. If you look on the internet, Googling images for the solar system, you get all kinds of images, but all of them have this kind of approach. And even if you use artificial intelligence and you ask ChatGPT, for example, to make an image, a realistic image of the solar system, this is what you get. So how can we address this misconception, getting the real feeling of astronomical distances in the solar system? The inspirations for the project came from 2 different projects. One was the Solar System Room in the Time Machines exhibition that TINAF, the National Institute for Astrophysics in Italy, organized in the last 2 years. It is a room where we had a sun, a 2.5 meter sun, and a map of the city where the exhibit was located, showing where the planets should have been with that scale. A second inspiration for spacewalk came from an online lab that we usually do with Edwina, our online magazine, called Build a Solar System Model using Google Maps. So the main idea behind the spacewalk was to develop an outreach and educational app to help understand the real distances in the solar system through a very practical and day-to-day experience, like a simple walk, something you needed to do physically on your own. There are some team, of course, this project was funded in 2023 by ENAF with a grant for our third mission institute. We had an internal team of people that you can see here in these slides, but we also had two external partners that collaborated with us to develop this project. One of the two partners is Explora, il Museo dei Bambini in Rome, which is a museum dedicated to children, and Arcadia, which is a startup from the northern part of Italy dedicated to AI and the use of AI in educational projects. So the idea is Spacewalk, which is a web app, so an app that you do not need to install in your phone. You just go to a web page to explore the app itself based on the GPS location of your cell phone. And the key concepts behind this web app are the fact that one step represents a real distance in the solar system. So from the beginning, when you start your walk, you know that one step of your walk will represent 1 million kilometers. And with this ratio, with this scale, you can make a walk of 4 kilometers, which is the usual the usual distance that we cover with a usual walk, going from the Sun to Neptune. Choosing the right places of the city where to locate the planets, you can have a physical walk around your city, exploring the Sun and searching for the planets and feeling the real distances of the planets from the Sun. When you find a planet, you can use augmented reality with your cell phone, of course, to learn about the planet, having access to a page of Edwina, an online page where you can find scientific information and basic facts about the planet that you can see in 3D, of course. So here is how it works for the user, some images of the app itself used during a walk. So the first image is the selection of the map that you want to use. In the second image, you can see the phone used to find the Sun. And in the third image, you can see the additional information that you can find in Edwina for the Sun and each planet. Of course, all these relates on having a good map in your city to represent the solar system. It needs to be a map that can be a walkable experience, where the planets are located in locations that can be reached, and the walk needs to be a good experience for the walker. So it all relies on the work of the administrators who need to build good maps for their cities to be walked, to be used to explore the solar system. The challenges that spacewalk we needed to solve to make a spacewalk. It is a web app. You don't need to install anything, but it depends on your GPS. So if you are using spacewalk in a place where the GPS doesn't work properly, it can be a challenge. There can be some problems of compatibility with different smartphones with different browsers, and of course we needed to simplify the solar system a lot, because the solar system, the planets are not aligned, they are not in a fixed position, they are moving around. So the image that we communicate of the solar system is a simplified model, but that can be explained, and additional information for teachers and students can be given with the activities that you can reach using the web app. So the present situation, we tested, it's still in a prototype, it is still a prototype. We tested it in an open day in the Museum of Explorer with teachers and with students. We also presented it at Didacta, which is a big exhibit for schools in Italy, the biggest one we have in Italy, in October 2025. We tested it with about 100 teachers on place, so we had a number of feedback and of comments that helped us fix a number of problems that needed to be solved before starting to create the maps. So future developments, after this test phase is finished, we will go on creating the maps to use spacewalk. The first use that we are thinking about is building touristic walks around enough observatories. We have 18 sites in Italy, and many of them are observatories, places, that museums, places that tourists and residents visit during the year. So the idea is to propose paths where the sun is located at the center of the enough site, and the planets are scattered across touristic sites of the city, in order to have a touristic walk around the enough site that help bring people to enough sites and have a different vision of our observatories. A second use we are trying to develop is an educational, is developing education multidisciplinary walks that also use astronomical information. This is because in Italy we do not have astronomy as a CP topic, so it is difficult to convince teachers to bring their classes in an educational trip about astronomical topics. But if we relate the astronomical topic with other topics in a multidisciplinary walk, relating them to geology, history, or other kind of approach, we can have walks that the teachers will use to make their children learn about the solar system as well. And the third use that we will develop in the next year is using the spacewalk as an indoor exhibit that doesn't need GPS to locate the 3D planets. We are planning to make a version with QR codes, with a QR code for each planet that teachers can use in the school, placing the solar system inside with an indoor walk inside the school, and making it as a tool for open days or for educational activities. So to know more, of course, you can contact me, and I am very happy to take your questions if there are any. Thank you.
Questions right now? And we do, okay, I do see one here in person. Quickly, please, because we are a little bit behind time.
Hello, Livia. Really nice talk and tremendous work. Something like that we wanted to do in Heraklion, in Crete, actually, in Greece, in another work. But I'm not sure if I missed it. You can use this application for how many cities? I'm not sure if you recommend.
There is no limit. You
Okay.
can, the important thing is to build a map for your city, and
Okay.
there is no limit in the number of maps
Mm-hmm.
that you can make. Each map is on a different web page.
Okay. You choose, for example, the location of the sun, and
Exactly.
application do the rest.
Exactly.
Oh,
But we need
perfect.
someone who knows the city very well to build a map that can be walkable and that can be useful from an educational point of view. So,
Okay.
Okay.
Perfect. Perfect. Thank you. Thanks so much.
Thank you so much. Let's give our speaker a round of applause. Okay. Our next speaker is Sudhir Phakatkar from India. I hope I said that correctly. Scaled ratio solar system, also online.
अरे काय करायचं आता Okay. Good afternoon. Very happy to be a part of CAP26 in Erevan as a representative of Khodat Rural Science Center. I come from a country where scientific temperament is not merely a matter of moral values but a national duty embedded in its constitution. Article 51H of Indian Constitution says that it shall be the duty of every citizen of India to develop scientific temper, humanism, and the spirit of inquiry and reform. Next slide, please. Yeah. Traditional textbooks visuals distort the solar system by shrinking astronomical distances to fit on a single page. This creates a misleading illusion of proximity and making planets appear crowded rather than separated by vast gulfs of empty space. Furthermore, these static 2D illustrations fail to capture the dynamic three-dimensional nature of the universe by flattening our orbital paths. They obscure the complex helical movements and spherical arrangements of our system. This lack of scale and dimensionality fosters deep-seated misconceptions about planetary mechanics and alignments. To truly bridge this gap, we must shift toward physical and scale ratio models that bring a real cosmic volume and motion to life. Next slide, please. To counter distorted textbook visuals, I developed a solar system model scaled down by a factor of 100 million. By using this consistent ratio, the inner planets shrink to tangible objects measurable in centimeters, while outer planets can be represented by familiar items like tires. The true power of this scale lies in its spatial realism. If a campus extends 500 meters, Mars can be placed at its precise scaled orbital distances. Anchoring these distances to local landmarks gives students an intuitive, profound grasp of immense expanse of space. Next, I have mapped our 100 million scale solar system model onto a familiar geography surrounding our science center. This proportionate chart serves as a spatial guide, translating immense cosmic distances and volumes into walkable or drivable map. By positioning the inner planets at local landmarks and representing their volumes through every objects, we transform a static table of values into a tangible experience. Next slide, please. Applying this 100 million fold reduction to the Earth Moon system creates a powerful hands on lab for exploring celestial mechanics. At this scale, a 12.7 centimeter Earth and 3 centimeter Moon clearly demystify the geometry of eclipses, seasons, and the regional Tithi system. This physical representation visualize the rotation paths governing time and highlight the relative thinness of our atmosphere. It also provides an intuitive way to demonstrate zero gravity, Lagrange points, and the proximity of artificial satellite networks. By shrinking this vast dynamics into a classroom space, abstract physics becomes a tangible, deeply intuitive experience. Next. By introducing a 1 billion fold downscale model with precision spheres, we can easily demonstrate planetary mass, gravity, and heliocentric dynamics. This highly portable setup visually captures the staggering distances to zodiacal constellations and stars, placing our system in its true cosmic context. Crucially, this dual model serve as a powerful catalyst for scientific temper, using physical reality to dismantle common astrological misconceptions. By contrasting immense distances with tiny planetary volumes, the model directly challenges superstitions, rituals, and unscientific beliefs. Ultimately, this scale culminates in its profound realization of our place in the universe, vividly illustrating a pale blue dot in the cosmic dark. Next. Scale down 1 billion times, the Earth Moon system fits perfectly onto a A3 size sheet of paper, making it an ideal interactive insert for textbooks. Rather than viewing a static illustration, students use this precise framework to draw the scale system themselves. Then, this hands-on drawing activity allows them intuitively grasp critical spatial concepts that are usually difficult to visualize. Through their own lines, they map out varying distances of perigee and apogee alongside the physical scale of light second. Ultimately, this active engagement clarifies the complex three-dimensional inclination of Moon's orbital plane relative to Earth. By taking both scaled solar system models into classrooms, I engage students in hands-on dialogue with physically mapping our true planetary distances using familiar local landmarks to measure the impact of this approach. I administer the exact same 10 question astronomy assessment before and immediately after the demonstration. This introductory test explorers fundamental cosmic scales, planetary sequencing, orbital mechanics, and the Earth's precise position within the Milky Way galaxy. Crucially, the questions also prompt students to define constellations and zodiac signs, drawing a clear line between astronomical science and cultural beliefs. By analyzing shifting answers, this pre and post test method directly evaluates how effectively the physical models dismantle deeply ingrained astrological misconceptions. Field demonstrations of the 100 million and 1 billion fold scale models brought vast cosmic distances to life through local landmarks and interactive storytelling. Comparing the pre and post sessions questionnaires yielded deeply gratifying results, revealing that students' comprehension increased roughly threefold. More profoundly, this newfound spatial clarity triggered lively discussions where students independently began questioning and debunking deep seated beliefs in astrology. Armed with scientific facts, they confidently dismantled traditional concepts like daily almanacs, auspicious timings, and horoscope based fortune telling. For an astronomy communicator, witnessing this rapid shift toward rationalism and dissolution of pseudoscience brings immense joy and hope for the future. While this assessment has been piloted on a select group, the upcoming Indian academic year will scale it across a highly diverse, multilingual student population. The student-centric phase will soon expand into targeted public outreach initiatives, liberalizing observational astronomy for all segments of society, equipping Communities with pure astronomy plays a pivotal role, fostering a rational worldview and systematically dismantling deep-seated superstitions like astrology and muhurtas. Looking ahead, the project will expand into collaborative field-based initiatives, including synchronized lunar photography to analyze purpose, uh, per- perspective shifts across different latitudes. Additionally, a year-long solar photography project will track seasonal shifts on the horizon, building a cross-border science network initially in India and then across continents. So in this way, I'm actively communicating astronomy to the public with a primary focus on students in the hope of fostering a strong scientific temper. In closing, I would like to express my heartfelt gratitude to the organizers for providing a platform at this esteemed conference to share these initiatives. Thank you very much.
Have any questions in the audience here right now? I'm waiting to see if any ones come through online. Yes.
Thank you for your talk. So you made this questionnaire to test on how students were learning better with these experiments, but have you thought of or done also tests on how their appreciation for astronomy has been impacted?
Yeah. Before giving questionnaires, I took answers from them, and then with detailed explanation and demonstration of both models, then that post test was conducted.
All right, thank you so much. Let's give our presenter a round of applause. Thank you. Thank you again.
Thank you.
And we can move on to our next presentation. We have, it looks like Sadie Coffin here in person, co-creating science, how citizen scientists help us democratize galaxy spectroscopy. And I will move out of your way so you can have the floor. Whoops, there we go.
All right. If you stuck with us so far, I brought stickers that I put on the side table. And if you were at Andrea's presentation earlier in the week, I was inspired to bring out my stickers for you all to have. So please take stickers before you go. Those are, I don't think it's shown up on the slide here, but my project has a logo of an astronaut with a lasso. So the stickers are of my project logo. Today, I'm going to be using my project, Citizen Science Project Redshift Wrangler, as a case study to try and answer a fundamental question in science communication, which is how to take a complex, abstract, highly technical concept like galaxy spectroscopy and make it participatory. So I'm going to share some of the strategies that I've used to try and scaffold and structure our kind of complex data to shift our volunteers from passive users to more collaborative researchers and members of our team. And I don't know if I can actually, I think I might have to ask, can you advance slide, please? All right, I wanted to quickly introduce myself if I haven't met you yet and give you a little bit about me. So that if I don't mention any of this in my talk, which most of I won't get to, please come talk to me about this during the week. Most of these things are unrelated to what I'll talk about. I'm a PhD candidate right now at Rochester Institute of Technology. Most of my PhD work is on galaxy spectroscopy, and I run the Citizen Science Project Redshift Wrangler, which is hosted on Zooniverse. It's a NASA citizen science project, and I've spent the last few years doing a lot of trial and error, and I've done a fellowship with NASA and the Association for Advancing Participatory Sciences, where I've kind of learned a lot of the strategies and frameworks I'll be talking about today. But I also am interested in talking about astronomy in bars. If anyone else has done Astronomy on Tap before or heard of Astronomy on Tap, please come talk to me about Astronomy on Tap. And I am the co-founder of an ethical outreach group, the community of feedback for ethical engagement. I always forget what COFFEE stands for, which was founded at another conference of astronomers interested in doing ethical engagement and outreach together. So if you're interested in any of this, please come talk to me separately. All right, please advance slide. So citizen science relies on public participation for our results, and on Redshift Wrangler, our problem at the beginning wasn't an interest in our science, it was an intimidation barrier. And our spectroscopy data was, we got this feedback that from non-experts, they heard spectroscopy and they assumed they would be unqualified and that it would be intimidating, and that the graphical data at the beginning when they first came in was something they felt unprepared to work with. So I spent a lot of time designing the project and working on the data to try and bridge that gap and create a variety of different resources, like this flowchart that you're seeing here on the left, which goes counterclockwise and demonstrates where the citizen science, where the workflow comes in to bring the contributions of the users into the collection of our data and the interpretation of the analysis, and where that all fits into the process of our science. All right, next slide, please. Instead of watering down our science to make it more accessible, I used what I'm calling a scaffolded approach, meaning I used multiple different entry points into the science to provide different ways to jump in. So there are a short tutorial or videos that you can use to dive right into the classifications without knowing much about the science behind what you're doing or the measurements, but you can actually jump in and start doing the classifications. Or there is more background on what our science means and what you're working on in an about page, and there are detailed annotated visual examples in the field guide. And then in order to dive deeper, there are talk boards. If you were at the keynote this morning with Laura Troy, Zooniverse has a talk forum where you can actually interact with the researchers. That's where we have places to ask questions and really dive deeper. All right, next slide, please. Some of the main learning points that I wanted to show here are on the right, and kind of the biggest one that I'm highlighting is that people, especially on our project, stay for the community, not just our science. So when we stopped viewing our audience just as data processors and started looking at people as collaborators and as colleagues and giving them space to shape our project too, it helped with both our volunteer retention and with the data quality on our project and the results that we were producing. So the left side here is showing some of the ways that we interact with viewers, with volunteers on our project, and build community on the project. And I've really started noticing how these methods have helped me shift from thinking about managing users to fostering community. And I'm noticing that starting office hours on Zoom, starting to provide a lot of feedback on these talk forums, and have regular updates and newsletters and interact with volunteers in all of these ways have shifted some of our interactions with our audience into co-creation, and some of these users have become more consistent and invested, and they've begun creating their own materials and collaborating with us on their own creations that they want to make, or even become part of what will become our publications. Next slide, please. All right, so this data from our project Redshift Wrangler is showing on the Y is our citizen science measurements, on the X is some existing catalog data. So the diagonal is where we are kind of proving an important point for me in science communication and citizen science is that people get better, or that volunteer accuracy improves over time, that these measurements that we were making in citizen science for this is high quality data for which we were able to make these measurements. We were finding the measurements, the values that we expected to see when the support was there, when we were able to provide the training and support and community that people needed in order to make those measurements. And so when our data showed that we were missing faint features or that we didn't provide the instructions that people needed to give us the data that we wanted, to give us the results that we wanted, we updated the instructions in the task, and I provided more training or more annotated examples in our field guide. Next slide, please. And I looked at more, it's blocking part of the data on the right here, but we're looking at information about the user data. So for each user, I looked at how long they spent analyzing a single object, a single spectrum, and I found that it was shorter than I expected. And the average amount of time spent on a single object was about 12 seconds. And so combining this user data with the outcomes that we were getting compared to catalog values, I kind of guided my approach to our training and our task instructions, and figured people needed more information on how to find faint features, on why it was important to find more than one feature in our data, and on why quality was important over quantity, why we wanted people to spend time on an object rather than classifying a lot of objects, as many as possible. All right, next slide, please. So I started noticing this link between communication, design, and data quality. And to wrap up, if you're working on citizen science or any kind of public science or astronomy project, I'd love to talk to you about it. I've kind of written down some of the open questions I still think about a lot and think are important for me to reflect on often and love to keep learning about. But there are obviously many more than this. So these are just some of the key points that I often come back to. And some of the main ones are who do I design for, and who are my communities, and is the public too vague? And also a key one on my project is what keeps people around. Is it the science or is it the structure and support? And I think on Redshift Wrangler, I've had a couple of participant surveys I've put out, and I've surveyed people to ask what motivates them to join Redshift Wrangler or to join Citizen Science Project, and it's both of those are really key, is both feeling part of something and also the science and contributing to our research and being part of our team. And also what the best way is to build trust in a large-scale project like Redshift Wrangler, and how we normalize making mistakes and making our task less intimidating while also providing clear pathways to diving deeper and becoming more of an advanced collaborator or an advanced user. So my kind of biggest takeaway is that I feel like I am still learning after 5 years of designing, running, launching, and maintaining the project, and I hope I will still be learning in a few years later. But I feel like I learn a lot from the volunteers on the project and peers and experts in the field, and a lot of people here as well. So I think it's a good thing to be continuously learning in this field. Next slide, please. I think this is my last slide. I just put up a couple of links here to, on the right is the project that I run with the examples of how I've scaffolded the information that I mentioned. And on the left is a kind of quick start guide that I created, which is kind of all the information to dive right in quickly to the project that I put in one place for either facilitators or for users on the project, to kind of be that first level entry, to start figuring out how to make more graphical multiple entry points into the project. So yes, I'd love to hear from you if you have any part in a project like this, or just want to learn with me or have anything for me to learn from. Thank you.
Thank you. Thank you, Sadie. All right, thank you, Sadie. I'm waiting to hear if we have any questions online. I don't see any yet. In the audience, yes.
Thanks for an excellent presentation. And it comes across that you're building a lot of valuable social capital with the community here. Constructs like trust, very interesting to unpack. But there was one particular construct that piqued my attention, which was ownership. So could you unpack that a little bit more? In what sense are you creating ownership? Was it a deliberate part of your strategy? Is it something that emerged? and tell us a bit more about that important construct of ownership?
Yeah, that's a great question. I'm glad you brought that up because I feel like that's come up a lot in presentations I've been in and in the ways I've been learning about citizen science. And I feel like I've learned about that along my journey, that I feel like I had to figure out that was an important thing for people, that I thought that teaching people about what we were doing on my project and then bringing them in was, I don't know, something very different than it ended up being, that I thought people would want to be brought in. I don't know, I kind of imagined it as more of a forceful, I'm doing this science and I'm gonna bring you in and show you exactly what I'm doing and make you a part of it. And it ended up being a much more fluid community experience where people came in, and I feel like when I realized that as long as I kept the community open for questions, and I kind of had to just make myself more open to answering anything people had within reason. I think I'm also learning how to have boundaries. That's a lesson I'm still figuring out. But being open to answering any question people have has actually changed what people want to do with the project, and the ownership people take with our data has like kind of made me really shocked that people want to do completely different science or research or exploration than I expected, when I just asked them, well, what do you want to do? What are you actually interested in doing, if I'm not just limiting them to coming in and telling them exactly what is happening here and what I want them to do. So I think the thing that surprised me the most was that, just kind of letting people know that I was trying to create a supportive community where they could come in and do what they were interested in, and that we wanted to foster niche interests, not that didn't have to necessarily be restricted to what the project mission was that I created. Opened the door to anything people wanted to do with our data, which is like publicly accessible, open data. So I started making it like a lot more of a, I have one goal, you may come in with many different goals, and I want to support what your goals are as well. But yeah, thank you for the question. I think about that a lot, actually, that the people coming in and creating a lot of different kinds of ownership on the project and meaning to redefine my goals over time really surprised me.
All right, thank you.
That's so true, yeah.
Yeah,
definitely.
That would be a great discussion to continue after. Thank you for bringing that up. Thank you,
Yes.
Thank you, Sadie. That was wonderful talk.
And I'm very sorry to people online that I brought up stickers as well.
All right. All right, and next, our next speaker, we have Anahí Caldú. And I'm sure I did not say that right. I'm so sorry.
No worries.
Keep the show on the road, best practices from a mobile planetarium project. The floor is yours.
Thank you very much. Yeah, I know my name is difficult, but I love when it's pronounced correctly. Anahí. So hi, I am Mexican, but I work at the University of Vienna at the Institute of Astrophysics. And because of the topic of the conference, I tried to do this first slide with AI. It took me a long time, actually, because they were putting the planetarium on top, you know, like weird, and then palm trees, but I thought we're in Vienna, you know. So after twitching it, I'm happy with the result. I hope you appreciate it, because it took me a long time, but that's the only thing I have related with AI now. So yeah, I want all of you to think, I guess all of you know a mobile planetarium. Just think what comes to your mind when you think about a mobile planetarium. And I'm sure, next slide, please, that this comes to your mind. So an inflatable dome, a projector. Usually with mobile planetariums, we have digital projectors, so something like that. And then software or hardware. And that's fine. That's a mobile planetarium. But usually what happens is that somebody comes with the idea like, oh, let's do an outreach project. Let's get a mobile planetarium. Somebody writes a proposal, and then you have a mobile planetarium, and then it's like, And now what? You know? So I actually, when I arrived in Vienna, they already had the mobile planetarium. But then for me, when I think about a mobile planetarium, next slide, please. Next slide, please. I think about this, the team. Who is working with the mobile planetarium? Who is the heart of the mobile planetarium? So here I have a picture of my current team. So I'm the coordinator. I coordinate a program of Astronomy to Go, it's called. And then I have, luckily, at the moment, a student assistant that helps me with all the administration part. And then the rest are planetarium guides. And without these great students, the planetarium is useless. Next slide, please. So there's a lot of people here. And the first problem is, how do I find people that want to work with a mobile planetarium? So I, luckily, can have an elective course for bachelor and master students, a workshop on the mobile planetarium. So they get ECTS points for the course. It lasts a semester, and I teach them how to use the software. We actually have a software that is based on Stellarium, but it has things built upon, so short videos, you can zoom in to very cool objects and some snippets actually. So I teach them how to use this software, how to use the hardware as well, how to put up the planetarium. They have a lot of self-practice, so they can just plug in the computer to a normal monitor and practice there by themselves. And at the end of the semester, they make a 10-minute presentation. It's not very long, but it's enough for me because I teach it during the winter semester. This is important because then by the end of the year, I know which people are good with are good doing shows with a planetarium, like they are good answering questions. And because I also practice like with different audiences, like I ask the students like to really play like, okay, you are 6-year-olds, ask questions as if you were 6-year-olds, and then the students are confronted to this, and then I also get a feeling if this is going to work or not. And this is my quality control. So I won't go much deeper into the details of this course, but if you want, I can talk to you about that later. Please, next slide. And then once I have found people, how do I keep them? Because usually also many science communication projects rely on voluntary work, as we all know. But you cannot keep such a project with voluntary work. So at the University of Vienna, we have found a way to give fair compensation for the students working with the planetarium. I know fair compensation is variable among different countries. For us, that means that students get about 20 euro per hour of work. And they get freelance contracts with the university. So usually they are like for the whole year, but they can quit before if they want. And each month they work 8 hours a month. Some students ask to work a bit more, but usually they all work for 8 hours a month. And they get paid like for the time they are driving to places, and for the time they are building up the planetarium, and for the time they are giving the shows. And I also, so as Sadie mentioned in her talk just now, I think building community is very important. So it's not also like they are workers and they have to do their job and that's it. So I try to hold regular meetings with my team. Regular means at least at the beginning of the semester, like the whole team together to see what's coming that semester, what are, if something changed, and at the end of the semester. And at the end of the semester, it is very important for me to really hear what they have to say, because they are the ones who are out with the planetarium. I'm coordinating it. I'm dealing with a lot of other stuff, but I'm not there. So then it comes the third point of implementing feedback. Like they tell me things and I can just say like, okay, yes, thank you. But I try to take into account as much as possible the feedback I get from my team. And here, for example, I noted the terms and conditions. Like a couple of years ago, students were sometimes complaining that they were getting to a school and that teachers were trying to fit in as many people as possible, whereas we say that it's for maximum 25 persons. And then I wrote terms and conditions that I added to the confirmation schools have to sign. And the students have access to this signed confirmation so that they can really defend themselves, like to have also a fair way of working. Next slide, please. Yeah, and other essential additional resources are that we have a web page in which all the information is very clear for schools or for anybody that wants to hire the planetarium, and the booking tool, which is also online. And there we have the information of what should they expect with the shows. We have very clear information on the costs and the space requirements for the planetarium. Then, as I said, at the moment, I have a student assistant, which is really very important. I mean, the student assistant I have now is with me 10 hours a week. But for the planetarium, I would say 5 hours a week would suffice. But this is really important. And the transportation. So we use the faculty's car, but we have to pay for it. It's not just that we book it and we use it. We have to rent it for each day and then pay for day and per kilometer. So now I am exploring the possibility of using a car sharing company in Vienna and maybe even making a partnership with them, because it would be, I think, more convenient. Next slide, please. And it's a non-profit project, but it's sustainable. And that means that it is like, for the people getting into the show, it costs like €3 per person, which is not very expensive. But even so, schools can always ask for reductions if they cannot come to the cost, like if they cannot complete the cost. And what happens with the money? So most of it goes to the salaries of the planetarium guides, so that they get paid and they keep on doing it. Then the rest goes to transportation. And sometimes if something is left, we just keep it as emergency savings in case the planetarium needs to be fixed, or, you know, things happen, or the car has something. Next slide, please. And is it worth it? So for me, that's the most important plot. This is when I started. It was after COVID, and we were only a couple of months working, so that's why it's so low. Then the 2023 was like a full gas, and we reached almost 7,000 pupils in the year, when we fit 25 people per show, so you can do the math. Then these 2 years go down, but it's because I was on maternity leave, like most of the time. So yeah, but you can notice I'm also important. Yeah. And now this is 2026, but it's only until May. So that means I think we are going to break the records. We are doing really well this year. And this is very motivational, like it's worth it. And here I also show a map, which you cannot see very well, but it shows also for this year only where we get. So we go not so far from Vienna, like 50 kilometers away, but we do reach other locations far away. And next slide, please. Last slide. So this is the take-home message I have for you. A mobile planetarium is a powerful way to bring science to schools, but it's not just to pump up this inflatable tent. There's a lot going behind scenes, and this has to be taken into account when thinking of a project like this. Thank you very much, and I'm happy to talk with you.
Thank you. That was really interesting, and I'd love to talk with you more about it later, because I actually used to do inflatable planetarium shows.
Oh, great, yeah, great. Very happy.
Okay, so I'm still waiting to see if we have any questions online. Do we have any in person right now? Yes.
Thank you very much, Anahí. Looks like a lot of fun. Okay. So do you have only the planetarium shows, or do you have also dedicated events with science talks, or like more complex? I mean, I don't want to bring a Noche de las Estrellas kind of thing, but you know what I'm talking about.
No, so I mean, this is, my job is being in charge of outreach for the whole institute. So this is one project, and I would say one of the most important ones also in terms of for the university. Like with these numbers in the University of Vienna, this is, I think, the most important project of science communication. But no, we also have, like within the observatory, we offer tours, like tours, open tours, private tours. We have monthly talks. there's not Noche de las Estrellas, but there's the Langenachterforschung, which is every 2 years, and that's the largest science fair in Austria wide. And we have a location at the observatory, and we have other smaller fairs. Yeah, so there's other activities going on.
Yeah, sorry if that was misleading. I meant
sorry.
together with the planetarium.
With the
like
planetarium.
Talks, like synergic events with the planetarium.
So science fairs, usually. Like we bring it to science fairs sometimes, yeah.
Hello, thanks. I also have undergraduate students who do outreach, so I had no idea I could expect this from the conference, and woohoo! I'm so glad you're here. My question is, you alluded to, but can you talk more about the reservation or request system, and if you have the whole semester, the whole year planned at the beginning, or if they come in and you take them?
Yeah, so the reservation system is what takes most of my time, or my students' assistant time, because I try to be super flexible to get to as many places as possible. So we take the reservations as they come in, and as long as we have availability, we book the visits. So yeah, that and we do it the whole year, no? So yeah, that's a lot of work. And what's most complicated is when the semester ends and then students don't know what their schedule is next semester. That's complicated because, I mean, you cannot stop doing reservations, but what I'm doing now is that we do like a pre-reservation. We send up confirmation, but with very big sign that when the students know their schedule, there might be changes.
All right,
So,
thank you. We have one more quick question from online, from Camilo Delgado Corral, and they say, are you currently producing your own planetarium shows?
So the thing is that with this software, we don't do shows, like it's not a movie. We never show movies. Like we really have a guide that does the show, him or herself. Like you really have a person there. There's the movies that we have are these short movies that are included in the software. That, for example, I many times show like Albireo, double star. Then you see that it has different colors, and then there's a short video that shows evolution of different types of stars, but it lasts 3 minutes. Okay, that's it.
All right, thank you so much. All right, let's give our speaker another round of applause. Thank you very much. And our next one is actually online again. I guess there was a mistake in the program, is what my colleague says. Okay, so we have Vincenzo Napolano, Immersive Experiences for Gravitational Wave Outreach from Italy.
Hi anyone. I hope you hear me well. Yes, I will. I'm Vincenzo Napolano. I'm in charge of communication and outreach of the European Gravitational Observatory, that basically is one of the 3 gravitational wave detector in the world, and 3 because there is also one Japanese. And dealing with gravitational wave astronomy, it means that you have basically to communicate to the audience and to let possibly experience the audience the result, the tools, the meaning of basically an invisible astronomy. So gravitational waves are not visible, and all the physics, the fundamental physics that is behind gravitational wave is quite complex. So the idea here is to create experiences in which people can somehow really experience with their senses some mechanism connected to these very abstract ideas of general relativity, for instance, or of the physics of black hole, or even the expansion in the universe, and so on. Of course, we work together with interaction designer and visual artists for realizing this kind of experience, but they begin from our concept. So the concept is the first step in which we decide which content focus on and which kind of interaction mechanism we want to realize. I will show you very quickly an example in this video, if possible. I don't know if I can show the video. I hope so. No, perhaps not. That's very bad. So I cannot show the video. No, okay. Anyway, I will try to describe with my speech. So for let's experience the people, the deformation of space-time, we create an installation in which a grid is projected on the walls, and basically with their own bodies, the visitor can deform, carve, and play with this net, with this grid, and creating oscillation, vibration, in a sense, a visual metaphor of gravitational waves. And they can also experience this kind of feedback between the mass, the presence of a mass, and the curvature of space. So it's a game, of course, as a ludic, as a gamey aspect, is a lot of fun, but there is also a clear mechanism that focus on some key idea of general relativity. So I put here a kind of checklist of what we ask ourselves when we are producing such kind of installation. So one point is this sensory immersive experience is accessible, which is the scientific focus of the experience, which is the game, the mechanisms that make it fun, that the game behind it should be a very simple mechanism, should be something in which people can engage easily. But behind this mechanism, there is some crucial scientific idea. As a visitor, I am comfortable in that situation. Is the installation able to create, to rising new relations, so new relationship dynamics? There is, of course, an emotional cognitive connection with the visitor, and always we check that there is not a unique behavior or reaction possible. So the experience should be open. I can react and behave in several different ways, and usually people behave and react in many different ways, especially kids, and some of these reactions are also surprising for us. So the behavior should be not predictable. This is a kind of checklist that I use for checking in advance if the idea that I am trying to realize could work. Another example that I would like to show, I'm not sure even here if I can put the video, I'm afraid not, is this one, in which we basically make an interactive installation about black holes. So the person, the visitor, see his or her own avatar on the screen, and this avatar coming closer to the event horizon of the black hole start to disentangle and then to be completely swallowed by the black hole. So the game here is to go closer and farther from the black hole and see is our figure of our avatar partially be destroyed and then be reconstituted. So that's the game. Again, is something just to kind of reflect and give curiosity about the enormous attraction force close to black hole, and then start a discussion, especially with school students and young people, about black holes, how they are, how they work, and which kind of object, of astronomical objects they are. Another one that is a bit more farther from the astronomical domain, but I think it's nice to understand the way we try to implement in a game also very abstract ideas, is this interaction about quantum mechanics. In this case, we have this object that continuously change their shape, and people can kind of put their hand on one of these, and in the moment in which they touch the object collapses in just one single shape, and then with time this shape will disappear. So this is about the collapse of the wave function in quantum mechanics. So a very complicated idea, but the idea we basically took one aspect of this complicated theory and transform it in an easy game. And the game, of course, is just the first step for then discuss further about physics and in the complicated idea there are behind. Something similar we have done also for application in several domains. Another kind of installation, for instance, is this one in which we allow people to discover the nuclear reaction there are in a star. So there is a video, but with your shape you can discover behind the video an abstract representation on physical reaction, and so on. We have also another one about the solar system and the Copernicus and Ptolemy models of solar system. So just for going to the conclusion, which is the philosophy that is behind this kind of experiment. Unfortunately, I can't show you the video, but I hope you catch something of that. The idea is to represent in a sensory experience very, very complex and very abstract ideas of contemporary astronomy, of fundamental physics. Let's say the trick is not try to be in competition for what concerns the technologies. In some cases, often we use very well established technologies, and we do not try to produce kind of special effect, also because especially young audience are already very usual with a high level of and continuous evolving special effect in games. So the point here is to find the good aspect of the content that you can transform in a kind of theatrical mechanism in which the user, the visitor, is the main actor. So the user is the black hole when we are talking about space-time deformation, is the observer that can make collapse the wave function, or in other cases is a fundamental particle that can interact with fundamental fields. So the user becomes the main actor of a kind of theatralization of a physical or astronomical mechanism. That's the philosophy of this kind of experiment. And that's all from my side. Thank you.
Thank you very much. That was very interesting. Questions from our audience here? All right. Oh, we have one from Sophie, right? Okay.
Hello, and first I want to thank you for tackling the very difficult thing, which is to not only convey gravitational wave exhibits to the public, but also in another talk you mentioned using interferometry and how an artist was able to kind of measure the vibration of some strings. I wanted kind of to focus on that exhibit you talked about yesterday, if it's okay, and just how it is you're able to pinpoint the origination of the vibrations in this type of exhibit.
Okay, just be careful that in that case we were collaborating with an artist that is Thomas Saraceno. So basically, the aim of the exhibit, it was not really an exhibit; it was something more similar to an artwork. It was not illustrating just illustrating a scientific idea, but more creating a kind of aesthetical and artistic situation. But just to, if I understood your question, what we did in this case was to let a model of interferometer. So there are very common this model of small interferometer Now it's perhaps a bit too long to explain how to work, but basically it's laser interferometry that are able to detect vibration that are in the environment. That's very easy. So you can have a laser and split into arms, and you build an instrument that is able to detect vibration. And in that case, working with the artists, we basically capture with the interferometer the vibration produced by a spider on a spider web. And this was then also transformed in sound. So it's a much more kind of magical, I would say, magic situation in which people can kind of experience an aesthetical perception and be curious about what is happening there. In these cases, the one that I showed today, they are more illustrative if you want.
Okay, and thank you. Is there a link maybe to the videos so that we can experience this?
Yes, there is a lead. You can search for gravity, imaging the universe after Einstein. But if you write me an email, I will try to point you on. You have my email here on this slide. I will point you on all the stuff.
All right, thank you so much. That was great. And we have our last speaker, Anjali. I am looking for the name of your presentation. It is Blended Worlds, Experiments in Interplanetary Imagination.
All right. Thank you, April. This is the wrong version of the presentation. Could someone pull up the PowerPoint version of it, please? That was the 20 megabyte PDF. But okay, so while we're waiting, I will go ahead and start. So this is called Blended Worlds, Experiments in Interplanetary Imagination. There may be more imagination going on in this presentation than originally planned. So we can do a new experiment today. So I will jump ahead a little bit on the off chance that we don't get there. So my name is Anjali Tripathi. I come from NASA's Jet Propulsion Laboratory. We're the NASA Center in Los Angeles. So we're the center. Yes. No dice. Yes. Can I present from my computer from the backstage? Can I try? You could try. Okay. So I will talk while I try and technical fix so that I will not waste more of your time, but I will just say there are NASA stickers for people in the room for your kindness, and spilling all over my bag, there are scents. So we can see if it makes sense to stay. I work at JPL, which is known as NASA's home for robotic exploration of the solar system. So we're at home to all of the Mars rovers. We don't do astronauts. And I say this because if I can ever get to showing you my slide, only MP4 videos are allowed. Ooh. Okay, let's try this again. Theme music. What's my name? Oh, I can tell you my name. That's a question I know. Please.
I feel like just the video will launch off because of low bandwidth. Because you're coming from JPL, and if I'm watching a live rocket launch, it always glitches and everything. You guys can launch a rocket to Mars, but you're not really very professional.
I'm not gonna take responsibility for how all of NASA media works. So I'm gonna. Okay, so it's saying it's uploading at 12%. So pardon? That's okay. I'm American. I understand. It's so I should also mention I have the title. So I work at JPL, but I'm also part of NASA's exoplanet exploration program. So at NASA, astrophysics is divided into 3 domains: physics of the cosmos, cosmic origins, and the exoplanet exploration program. So I work in that last one. And I have the really interesting title of being NASA's exoplanet science ambassador. Which means that I go and do outreach, I do media, I also help develop both for the technical community, professional development, all kinds of products and engagement. So if any of you would like me to come and speak at your institution, that's part of what I do. Although because I work for the US government, my budget is a little more limited these days, so maybe you can help with that. But I still brought stickers for all of you. Okay, 34% of the way there. So we aren't halfway there, so I won't burst out singing. But what I'm going to show you is an exhibit that was funded by the Getty Museum in Los Angeles. So for those of you who may not be familiar, in Los Angeles, we have public art museums, but there's also a very prominent private museum called the Getty Foundation. And what they do is every 7 years or so, they provide funds to Los Angeles institutions to work on some topic of their choice. So the previous iteration to what we did was LA. So it was like Latino was one of the LAs, and I forget what the second one was. The one that we put in for in about 2020 was called Art and Science Collide. So JPL was not the only institution. There's an amazing catalog of institutional work that was done, all of this, observatories, universities, art museums. There were ones about like the pigment that you use in cinema film and this kind of thing. So I encourage you to check that out. And what I wanted to present to you was what we did for our exhibit, which was we took this funding and we decided we wanted to use it as an opportunity to be able to fund some artists who we would love to be able to work with for different things. So one of them, for example, was Annette Lee, who some of you might be familiar, who is part of an Indigenous Skywatchers group that she leads. I'm not going to be talking about her project because I'm going to focus on the 3 rooms of this exhibit that had to do with exoplanets. And so, like I said, this is called Blended Worlds, Experiments in Interplanetary Imagination. This is a title that one of my colleagues came up with because he said when you're thinking about something like exoplanets or lots of astrophysics or solar system physics, you're sort of right at the edge of being able to understand what it is, and you're at the edge of what is and what if. And when people talk about knowing, like in English, we just have the word to know, but in other languages, you have like knowing someone's phone number and knowing them as a person, and those are different verbs. And so thinking about for us, what does it mean to know something, and have these thought experiments of what would that knowing something about, when I say I know an exoplanet, is it just I know its name, or how big is it, or what it's like to be there, to really think about that process. It says it's finishing up. Okay. Hopefully that won't mean I'm off the stage in 30 seconds. And so what it was is we took over a room of a library, because again, we used the funding to fund artists to partner with me and a couple other scientists. I'm an astronomer by training. And for me, I was paired with a lovely perfumer and a sound engineer and one of our designers in-house. And so what we decided to do was we wanted to bring people on a journey to the exoplanets, which in some ways are very familiar. Like if you found an exoplanet that looked like Earth, maybe that's incredibly familiar. Aha, it's here. Okay. So I will tell you more about that in a second. This is my friend Chris. Chris is in space. I got to talk to him while waiting for my flight to come out here the other day. And I show you this picture though, because when I tell people I work at NASA, they're like, oh, are you an astronaut? Oh, you're not an astronaut, you're an astronomer. But you can be an astronomer who becomes an astronaut. And I say this because we will come to auroras later in this. But I think for a lot of people, when you talk about space and astronomy with the general public, astronauts always come to mind. And so when we're talking about these experiments in imagination, that notion of being an astronaut in the future, or your future self, is part of it. I don't know if I'm driving. Am I driving? I'm not. Okay, next slide, please. So when we talk about exoplanets, like I said, about knowing, the fact of the matter is astronomy is this beautifully visual subject, but exoplanets, if you go to the next slide, are nothing more than stars. Next slide. That are just known around different stars, right? And so in some ways, an exoplanet, its name is by definition from that star. There aren't a lot of visuals. If we go to the next slide, you'll see of the 60 to 91 exoplanets we know today, only 101 have actually been imaged. And when we look at them in this non-video, so you can imagine those pixels are actually moving around in a circle. That's for the system HR 8799. Those are planets big like Jupiter, far away from their star. They're going around in circles. It's not more than a couple of pixels that you're seeing. And so for capturing someone's imagination and knowing, there isn't a lot there. But if you go to the next slide, you'll see that as NASA's exoplanet program, we try to provide resources to make exoplanets more accessible. So how many people here are familiar with Eyes on Exoplanets or any of the NASA Eyes products? Great, thank you. For the rest of you, please go to eyes.nasa.gov. We have resources about the Earth, asteroids, solar system, and exoplanets. There, you won't see a video here, but if you go and visit, you can actually, so this is what, the sky will look like from Yerevan later today, right? So this is in Cygnus, the Kepler field, but you can actually see 3D renderings of every exoplanet host star and of the exoplanet, and you can get information about, what are the naked eye stars available to you tonight, what's some pop culture about the systems. There's a whole bunch of information, and that's sort of like the 0th level of knowing the system, right? You can get its basic parameters and where it is. If we go to the next slide, you'll see some of our more familiar products. How many of you have seen our travel bureau posters? Okay, almost all of you. So that comes out of my office, right? So we're really blessed to have a great budget to be able to spend on art. And again, we try to make it more accessible. So we have different language versions, English and Spanish for some of these. We have coloring book versions. Bottom is actually a VR version we did of the surface of these planets. So if you go to our website, you can see that you can put it in a headset. So on the bottom, it's actually showing you that if you were on a moon of that planet, what it would look like to see the planet in the sky with the 2 stars. Next slide, please. So like I said, we did this exhibit. It was the end of 2024 into 2025. We started planning for it in about 2020. And if you go to the next slide, you'll see that that wall that you see people looking at is giving you the names of different experiments you could have. Some of them, the ones with the yellow highlights, are ones that we actually realized, and the other ones are just fun names. Like you might see space station beekeeping, or Earth phases from the moon. Again, sort of imagining in the future what it's like and being at that intersection. So on the left of our venue, which is actually a public library in Los Angeles that has an art space that they let us use. You can see the floor plan on the bottom. So each of those green boxes is a different exhibit. On the next slide, you can see that on the bottom row in the middle is what I had the opportunity to work with. And so that was 3 pieces. So if we go to the next slide, we'll actually talk about what the guiding theme here was. So I mentioned I got a chance to work with a perfumer and an audio engineer, and we were thinking like, how do we work together? And we thought we're gonna take you on this 3-step journey to the exoplanets. So we're gonna take you from the really familiar world of the Earth to getting to the distance of a distant star and then actually getting to know that exoplanet. So it's really easy for us to talk about how do we feel connected to the exoplanet in a today we are on Earth in that direction, but I think it's equally important to go in the other direction of if we're in the far future and Earth is like this distant memory, what was it like? So I'm actually, as I talk about this, since it's easier to talk about sight, we're going to start there and we're going to work our way back. And in the video that you're not going to be able to see, that's what it's going to do too. So if we go to the next slide, you'll see a picture of a sunset on Mars, which for people who have never seen a picture of sunset on Mars, it's very confusing. Why is it blue? Right? And that is a feature of sunset on Mars. And so even just, oh, okay, sure, yeah. No, we can go to the next slide. That's fine. I should hurry up. I've talked for too long. So in what we were trying to represent for exoplanets and actually being there, and if you're going to see it, is what does sunset look like on an exoplanet? So on the right is a video or a screenshot of code written by Zach Berta Thompson at the University of Colorado, who has a GitHub repository called Rainbow Connection that will actually simulate sunsets for you on different planets. So it will take into account what's in the atmosphere that's been detected, how high you are. So if you actually saw this video, you would see a dot come down, which would be the sun setting in the sky, and you would watch the colors change. So like at daytime, it would be blue, it would get orange on Earth, and you can see how the spectra shifts. On the left, though, is a picture of what the exhibit actually looked like. So what you see is this ring. It's not just a circle for technical reasons, and it would change colors for the sunsets of an exoplanet. And then, of course, what's more beautiful than auroras? And that's why I had that picture of Chris, where he's an astronaut looking at auroras on Earth. But what if we were actually looking at auroras on an exoplanet? And you could have that opportunity to stand there and watch that all shift. If we move along to the next step, so this is, we were on that planet, and now we sort of move back towards the Earth. This is a room where I'm going to actually just play the sound for you because the visual is less important with it being a sonification, but I'll explain it first. And this is, you have this wall, which looks a little bit like the Kepler field of view, which was by design. Kepler, of course, being the spacecraft that discovered 3,000 plus exoplanets. And it actually, in the middle, has a display that shows you a view from eyes on exoplanets. So what happens is on those panels, you would have them light up with 8 different exoplanets. So just pulling out of the NASA Exoplanet Archive, 8 randomly selected planets. They're each assigned a musical chime, totally random. And then they will play with a pause related to how far away they are. So you get a sense of what's close and what's far. So we're going to listen to that real quick with my very technically savvy. Okay, so I don't know how effective it was. I sincerely apologize to everyone for my technical difficulties, but the idea is that you didn't hear everything all at once. There's some delay, and so what you would see is different planets would pop up. You would see the weird letters that are their names. And if a planet happened to be in the habitable zone, which is where it can sustain water on its surface potentially, then you would actually see an image like what's on the right from Eyes on Exoplanets showing you that system's configuration. Because we spent a lot of time thinking about what would make sense to present as different variables for the sounds. And we decided to keep it simple. It's random. All you get is distance to get a sense of how far or close this is, but to be excited about some systems. If we go to the next slide, though, we'll go to the room that I think draws the most interest, which, and the other one was called Interstellar Soundings. This one is called Sensory Mementos. And this is really a room that works in both directions of present and future. Because the way it worked is there were 3 walls, so you can see 2 there. One of them was lined with, there were about 40 scents, and one wall was lined with scents that were like horse stables, pancake breakfast, gin and tonic on a Saturday night, Proust Madeleine, Rose Garden, things that if you just smelled, that people in this room would be able to identify at least some of them. On the other wall, where you can see the gentleman there, they're actually smelling lightning on Saturn, Enceladus geyser, rock garden on Mars, clean spaceship, interstellar cloud. And for all of these smells, we worked together to try and identify molecules that would actually be accurate. And then, of course, there was some artistic interpretation. And so it ended up being the idea that right now those are foreign smells to us, but maybe in the future that wall will be familiar and the other one will be foreign. So just moving swiftly along, if this is a video that's not going to play, but you can see the sunset that's walking through. If we go to the next slide, and I'm happy to show the videos to all of you afterwards. I'm showing you what happens if you have money from museum exhibit to work with artists, and we funded the installation itself. For most of you, that's not going to be realistic, and I get that. It's not realistic for me on most days. And so what we tried to do is, how do we distill this into alternative packaging? So one of them that we did was, I said, well, let's just take 3 of those scents and let's try and pair them with different kinds of exoplanets. So I imagined like a gas giant planet. I imagined sort of a habitable world potentially, and then a world that is actually inhabited. And so I associated 3 scents with them. So here I associated lightning on Saturn, seaside in the fog, and technosignature with them. And so then what I did is we printed these little cards, so you can see our little box 1, 2, 3. And for those of you who wanted to do this, you could even just stop there with Post-its and ask people, what would an exoplanet smell like? Because it turns out when you try and ask a bunch of exoplanet scientists, nobody's sure what to do. And I'm almost done. This is my second to last slide. But what we did with this exhibit is we packaged the scents in these little scent rollers that you can buy on your favorite purveyor of all things. It's got a little roller ball. This is number 3, so I should match the numbers. And so we would apply scent on these cards that I had designed, and then we would give them to people. We did this at the American Astronomical Society meeting a couple years ago. So you'd take a sniff, and then you have to guess, what am I smelling that has actually been detected in the atmosphere of an exoplanet? So then you'd flip it over, and on the back, you can see it has something in red that shows you what has been detected. It explains a little bit about that. It takes you to a QR code. And it's sort of a game. So I put number 2 on here so that nothing is given away, but I have number 1 and 3 with me. So all of you in the room can try this out. And I say this because, for something like technosignature, hairspray is a great technosignature. If you have a civilization that's got hairspray on its planet, there's life there, right? That's not a natural occurring thing. For the first one, you have ammonia and Windex, right? Window cleaner, glass cleaner. So I just want to encourage you that you think, this is NASA and they have all of their resources, but actually there are ways that you can use common items that you have available to you to just really think about, where can we make this a sensory experience? So my next and last slide just shows you some of our design principles that we kept in mind as we were doing this, right? Which is, and I think the first one is really telling. Again, we started working on this in 2020. We wanted to talk about humanness versus machineness, right? Of how are we having that human experience? And actually this whole exhibit is really, there's a lot about nature in it, right? One exhibit had grass blowing in response to wind from Mars from the rover data. So you could feel the wind on Mars, you know, and thinking about, we produce these in a very rough thing. It's not very aesthetically refined. It was supposed to be very experimental and really driving at questions. So for those of you who are interested, there is a documentary that PBS made about this process. So you'll see our exhibit and a couple others in it presented there. That's that super tiny QR code, but it's also tinyurl.com/blendedworldsdoc. And again, I encourage all of you to make use of all of the resources. They are funded by the American taxpayer for you to use, which is our Travel Bureau posters available for downloading, Eyes on Exoplanets, and lots more. So I'm happy to answer any questions, and there will be the Sense over there for you to try, and anybody who wants an I Heart Exoplanet sticker, it's there for you too. Thanks so much for your patience with everything. Oh, and please don't steal my sense. Thank you.
I'll try not to. All right, thank you so much, Anjali. I know that we're, the time is a little bit funny with 7 speakers and everything. I don't think we have any online questions right now for Anjali. Any questions in our room for Anjali or any of our other speakers? Or is everybody ready for some stickers and some dinner?
And smells.
And smells.
You came for the smells.
You have a question? One question? Okay.
First, I want to say thanks because the NASA resources are incredible. I always use them to do my talk of outreach. Then I have the question: do you have the simulation of an exoplanet in a binary system and to see the alba of 2 suns?
So in that picture that I showed of the VR, it's static, right? It's not moving. So you can see in the sky 2 bright objects, but it's not dynamic. But we do have that, yeah. And I'm around. I'm happy to answer questions again. I'm sorry to keep everyone late. Thank you for your patience. Oh, I see there are other questions.
Okay, one more question. All right.
I know NASA doesn't think about making benefit, but do you think that maybe a cooperation with a perfume manufacturer to have an exoplanet perfume?
I think if you want to make that, that is all you.
Okay.
We're not in the business of developing things ourselves. We're all about turning it over to people to develop themselves.
I was just going to say we are lower budget science museum, and you can go to places like grocery stores that will actually have this like apples. If you smell apples in an American grocery store, it's not always apples. A lot of times it's like a chemical packet, and they recycle them faster than they actually run out of smell. And so these are places, or like Hollister, that you might be able to get some scents from without the perfume industry.
All right. Well, thank you so much. Let's give Anjali another round of applause and all our speakers. And that's it for today. We'll see you tomorrow.